Okay, let me start the presentation.
Yes, you can.
Yeah, good morning, ladies and gentlemen. My name is Nam, and I'm come from EVN PECC4, one of the leading consulting company of EVN. And today, on behalf of PECC4, I would like to introduce PECC4 study on sub-synchronous resonance for thermal power plant connected on Vietnamese grid using EMTP. So the slide contains 4 parts. The first one is a sub-synchronous resonance phenomenon. The second is a SSR issue at Vũng Áng 1 thermal power plant in Vietnam. And the third one is analysis of SSR at Vũng Áng 1 thermal power plant. And final, how to mitigate the SSR for thermal power plants connected on Vietnamese grid. So first of all, let's come over to the definitions of the sub-synchronous resonance, SSR, defined by IEEE. So an electric power system condition where the electric network exchanges energy with a turbine generator at one or more of the natural frequencies of the combined system below the synchronous frequencies of the system. And the series capacitor compensation used in AC transmission system may cause the natural resonance frequencies is defined by below formula. So the current in the rotor winding will be induced at the complementary frequency FR equal to F0 minus FER. Rotor currents result in sub-synchronous stator voltage components which may enhance the stator currents to produce the self-excitation phenomenon. And interaction of the aforementioned stator flux rotating at sub-synchronous frequency with the rotor DC flux rotating at frequency FR develops an electromagnetic torque at a frequency. And frequencies of this torque component close to a mechanical natural frequencies of the drivetrain system. The torsional interaction can produce undamped oscillation between the drivetrain and the electrical network. And SSR may lead to torsional oscillations of the turbine generator shaft system. And SSR will cause failure on the generator turbine shaft and instabilities of the power system at oscillation frequencies lower than the normal system frequency result from SSR. So let's come to one study case at Vũng Áng 1 thermal power plant. So this project located in the center of Vietnam, and it had the capacity of 1,200 megawatt, and it was series in 2014 to 2015. So, and what happened to this power plant? So in November 2015, during the operation of 2 units, a strong vibration was recorded at the shaft bearing number 7 of the turbine generator. And after checking, the rotor shaft crack was detected at the shaft bearing number 7 of unit 1. So you can see here the image of the cracks on the bearing number 7 of unit 1. And then Toshiba concluded that a fatigue crack caused by the sub-synchronous resonance formed by the torsional oscillation when interacting with Vietnamese grid. As you know, in Vietnam power system, the series capacitor compensation had been widely used. And this generates the low frequency component which interact with the mechanical natural frequencies of the Vong-Ang-1 plans sharp to amplify the top. And you can see here one image of the Vietnamese power system. So to increase the capabilities of transferring power and the stabilities of the transmission line, as well as sharing the load between the parallel transmission line, several series capacitor compensation was equipped for Vietnamese 500 kV transmission system in 2015 as follows. You can see here for Da Nang bus bar, we have the capacitor. And for Da Nang substation, we also install the series capacitor. And for Nho Quan bus bar, we also install the series capacitor. And Vong Ang substation, we also install the capacitor. So the electrical damping torch is calculated through a scan of system impedance looked out through the rotor of the study generator. And a positive value of electrical damping indicates that the electrical system has a stability effect. And on the other hand, a negative value of electrical damping indicates the electrical system has an unstable effect at the given frequencies. So you can see here the two I bar represent the mechanical damping torch of the first two torsional modes of Vong-Ang-1 units at nearly 14 Hz and 27 Hz. A torsional mode is unstable when the damping torch dips below the top of the Y bar. And the point where the damping torch cut through the I bar gives an indication of the low level below which mode will be unstable. So we have prepared the simulations for n-1/4 of transmission line. The result indicate the n-1 operating conditions cause the electrical damping torch to dip below the bottom of the I bar, which means the mode number 2 would be unstable even at high load. The SSR analysis from this figure confirms that Vong-Ang-1 plant has SSR risk for many operating conditions. The SSR condition is extreme for transmission outage condition n-1 or n-2. The second torsional mode will be unstable for a large number of the transmission outage, regardless of unit loading. So you can see here the mode number 1 and not mode number 2. And we have created the modeling of Vong-Ang-1 thermal power plant using the EMTP software. And we carry out the simulation for this power plant. And you can see here the results of the simulation. So through this simulation, we can conclude that the sharp generator crack incident at Vong-Ang-1 thermal power plant in Vietnam in 2015 was concluded because by SSR phenomenon, and we can prove this by using EMTP software. The second, electrical damping torch calculation result show the potential risk of SSR occurrence at Vong-Ang-1 thermal power plant under many operating conditions. And the last conclusion is SSR analysis through EMT simulation using EMTP help to evaluate the influence of SSR on the turbine generator structure and determine the amplitude of torque oscillation for protection setting. And how to mitigate the effect of SSR on Vietnamese power grid, especially for thermal power plant. So we would like to introduce three solutions. The first one is using the thyristor control series capacitor TCSC. The second solution is using STATCOM, and the third one is using the SSR series blocking filter. So first of all, I would like to introduce the TCSC solution. So as you know, TCSC had the function of optimizing the power transmission, increasing system stability, and reducing the sub-synchronous oscillation. And they are used to replace the old type fixed series capacitor, causing SSR. And we make the simulation with 2K. 1K we don't use the TCSC, and 1K we use with TCSC. And you can see here the difference between the 2K. So when we apply the TCSC for the power system, we can see the oscillation damp very quickly. It means it will bring the power system and especially the thermal power plant the stability. The second solution is using STATCOM. So a STATCOM is HPC based on voltage source converter, which generally used for reactive power support or voltage regulation. But with the auxiliary controller, it is capable of SSR damping. And the STATCOM's configuration is due to dampen SSR, and it consists of a voltage source converter, a coupling transformer, a DC capacitor, and controller unit. So we simulate the fault with two cases. For scenario 1, we consider a three-phase to ground fault on 500 kV Hà Tĩnh to Vũng Áng, this line. And we carry out the simulation at 0.1 second with the point of fault at 500 kV Vũng Áng bus, this point. And the fault will be clear after 0.17. And for scenario 2, we consider a three-phase to ground fault at 0.1 second on the same transmission line at the bus 500 kV Hà Tĩnh bus. And according to the simulation for this transmission line, for these two bus bars for scenario 1 and scenario 2 simulation, we can see that when we install with the STATCOM, the oscillation damp very quickly, and it brings the system the stability. And the last solution I would like to mention is using the SSR series blocking filter. So the blocking filter is installed in each phase of the neutral point of the generator step-up transformer on the high voltage side. And this requires the transformer have exposed neutral point, and SSR blocking filters is a low frequency resonant circuit with the inductance and reactance connected in parallel. with a filter state for each torsional mode. And this type of filter has been used at the Navajo factory in Arizona, America since 1976. And this is the value we carry out the simulation for Vũng Áng 1 thermal power plant. So when we use the series blocking filter, you can see on the left hand side chart, this indicates for the case of we don't use the SSR. And on the right hand chart, in this case, we install with the blocking filter. And you can see when we install the blocking filter, this is very safe compared to the solution that's not using the blocking filter. Yeah, so what happened when we apply the blocking filter? We can see here the simulation. When we use the blocking filter, the oscillation damp very quickly compared to the case that not using the blocking filter. So I would like to come to the conclusion. So the first one is SSR is an important problem in the power system, and especially the series compensated transmission line might cause the SSR in the turbine generators, leading to the electrical instability at sub-synchronous frequencies and potential turbine generator shaft failure. Second, the SSR phenomenon was first recorded in Vietnam with the case of Vũng Áng 1 thermal power plant in 2015 due to the interaction with the series capacitor compensated transmission system, causing the cracking of the turbine generator shaft. And electrical damping torque calculation result show the potential risk of SSR occurrence at Vũng Áng 1 thermal power plant under many operating conditions. EMT simulation using EMTP helps to evaluate the influence of the SSR on the turbine generator structure and determine the amplitude of the torque oscillation for protection setting. And the last one is solution for reducing SSR was studied as such as replacing the series capacitor by the TCSC or STATCOM system, and even install the SSR blocking system. The time domain simulation result on the transient analysis show that the SSR of Vũng Áng 1 and 2 thermal power plant is analyzed through the torque oscillation between shaft sections of the generator motor, which is greatly reduced under the three-phase short circuit fault in the power system. So till now, my presentation is over. So once again, thank you for your listening.